It is important to properly preload tapered roller bearings that are typically found in tube, pipe, and roll forming mills. Preload is defined as the amount of inch-pounds of rotational force that is required to continually rotate a shaft when tapered roller bearings are properly tightened. Preload is most commonly measured with a dial-type inch-pound torque wrench, not the clicker style. Proper preload is very important because if a bearing is set too tight, you can cause premature bearing failure. If the bearing is too loose, you're going to cause mill alignment issues because the spindle can move back and forth, which will affect your alignment. There are two typical ways of preloading a bearing. One method is using a bearing retainer and shims. By adding and removing shims, you can adjust the preload. The other way, typically, is using lock nuts. In this case, we're using a double lock nut. The first nut pushes up against the bearings to set the preload. The second nut locks the preload in place so it doesn't loosen up. Use a spanner wrench in the front part of the shaft, or the roll space part of the shaft. You can lock the shaft in, so this way when you're tightening a nut, you have something solid to tighten against. Using the spanner wrench on the nut, and sometimes a lead hammer to tap it down, tighten the first lock nut. Once that's done, you use a lead hammer to ensure that the bearings are seated, tapping on both ends. Make sure that the shaft rotates to the point where you don't feel any clicking. And check the bearing for end play. If the bearing feels smooth and there's no end play, grab your torque wrench. Next, find a way of securing a fastener to the shaft. In this case, you can use a bolt because there's an internal thread. In some cases, there's an external thread which you can put a nut on and then use the appropriate socket with your torque wrench. For this particular bearing, we need to achieve about a 10 to 15 inch-pound torque reading. At this point, the rotational torque is at 12 inch-pounds. So we're good there. If it's too tight, you're going to have to back the nut off to loosen it up. If it's not tight enough, you're going to have to continue to tighten the nut until you achieve the proper preload. Once the proper preload is set on the bearing, you need to come back and tighten the second nut. Lock your spindle in using a spanner wrench. Then tighten the second nut, making sure that a tab on a lock washer lines up with the tab on a lock nut. Once that's done, you must go ahead and hit the spindle again with a lead hammer. Check for bearing in play because tightening a nut will have effect on the preload. And then grab the torque wrench and again check the torque reading. We're now at about 14 inch-pounds, which we're going to leave it there because we are within the recommended torque reading. Once the preload has been properly set and verify with the torque wrench, pound over the tabs, one tab into each lock nut. Once that is complete, install all oil seals and grease the bearing by rotating the shaft while applying the grease. A properly lubricated bearing that has been preloaded to the proper torque specifications should last for years.